Hi and welcome to Sciencey Maths. Today we're going to learn about the half-life and look at a couple of examples. So what is a half-life? Well, a half-life is the amount of time it takes an object such as the element uranium to decay into half of its original mass. We can also use this equation to find the inflation rate of a product and use it with other similar data. It can be represented as this equation: A equals P times E to the power of RT, where P represents the starting amount, R is the rate, and T is the time, and A is the amount after the time represented by T. Example 1. We have a substance with a weight of 100 grams. We want to find out how much it'll weigh after 4 years with a decay of 95%. And we know it is decay, so we'll take 0.95 and minus it by 1. So we get negative 0.05 as our rate of decay. Then we'll put all those variables into our equation to find A. And we put that and simplify it down and put it into our calculator, if you kind of have to with the E, and you get 81.87 grams. And therefore, after 4 years, with a decay constant of negative 0.05, approximately 81.87 grams of our substance will remain. Example 2. Let's say we have Captain America's shield, and even it, the mystical metal, has a half-life.
Vibranium is stronger than steel and a third the weight. It's completely vibration absorbent.
How come it's not a standard issue?
That's the rarest metal on Earth. What you're holding there, that's all we've got.
Its initial weight is about 5.5 kilograms, with a half-life of 500 centuries. That's a long time. So what is the half-life rate of vibranium? And how many kilograms will it be after 75 centuries? First, we'll put 500 in for T. And since we're looking for the half-life of P, we know A is equal to 0.5 times P. Then we simplify the problem by dividing both sides by P. And to make it also a little easier, we'll swap the sides. And so we get e to the power of 500 r is equal to 0.5. And we'll use the natural log rule and then divide it by 500. And we get this big number, or negative 0.14% or 86%. So to check our answer and to get a more accurate answer, we'll put the unsimplified rate into our equation, like so. And we put that into our calculator, boop, 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 and we get 2.75 kilograms. And we know 5.5 divided by 2 is 2.75. So that's right. Yes, we found the decay rate. So we'll put 75 centuries in for T. And so there it is again. And we put that into our calculator and we get 4.96 kilograms. It's as easy as that. We know that after 75 centuries, with a decay rate of about 0.86%, approximately 4.96 kilograms of vibranium will remain. But remember, some mistakes that I have seen with this equation is mixing up the percentages when finding decay or increase, and when to add a 1 or minus 1. And always remember your negatives and keep track of them, because they will bite you in the butt, and it'll make it really hard. Alright, I'll talk to you later.